Alright, welcome. How's it going? Welcome to the channel again. I'm Joey, and today I'm gonna be doing some deciphering. Let's decipher some codes. It's a very interesting challenge I got for you today. Again, I'm in my virtual machine using Ubuntu, and I'm doing over-the-wire challenges. This time I'm on Krypton levels, and level 4 is a really interesting one. Let me show you just what I'm talking about. So let's start by connecting it by SSH. So I want to connect to Krypton 4 at krypton.labs.overthewire.org on port 2231. And the password is capital brute. Oh, I mistyped it. There you go. So let's navigate to the folder. It's on Krypton 4, and they have a few files there. Let's get the README first. So cat README. Okay, good job. You more than likely use frequency analysis and some common sense to solve that one. So far we have worked with simple substitution ciphers. They have been monoalphabetic, meaning using a fixed key and giving a one-to-one mapping of plain text to ciphertext. Another type of substitution cipher is referred to as polyalphabetic, so that's what we're working with, where one character of P may map to many or all possible ciphertext characters. An example of a polyalphabetic cipher is called a Viennese cipher. It works like this. If you use a key K, like gold as a key, and P as proceed meeting as agreed, so P would be the plain text, and then add P to K, so add the plain text to the key, we get C, or the cipher. When adding, if we exceed 25, then we roll to 0, so that's the modulo 26 because there are 26 letters in the alphabet, so we're still working with the regular alphabet. So here you see the plain text, proceed meeting as agreed. Here you see the key gold, 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 gold. And here you see a numerical representation of the same thing. So for example, letter G is the 6th letter on the alphabet. Letter P is the 15th letter on the alphabet. 15 plus 6, that's 21. And letter 21 in the alphabet is letter V. So the ciphertext of proceed meeting as agreed is this big blob of nonsense right here. So in order to decode this, you need the key. What happens when you don't know the key? Well, that's what we're going to figure out today. This level is a Viennese cipher. You have intercepted 2 longer English, so that's important, language messages. You also have a key piece of information. You know the key length. For this exercise, the key length is 6. That's really important and really helpful as well. The password to level 5 is in the usual place, encrypted with the 6-letter key. So let's see what messages they give us, and they only tell us the key length is 6. We don't know the key. We've got to figure it out. So I see that they have a found one. Nice. They have a found 2. Nice as well. They have a hint. Frequency analysis will still work, but you need to analyze it by key length. Analysis of ciphertext at position 1, 6, 12, etc. should review the first letter of the key in this case. Treat this as the 6 different monoalphabetic ciphers. Well, that will help you a lot. That will help us a lot, really. And you'll see what I mean by this when you start coding. And also, we have the crypt message, which is on Krypton 5, which is this thing here. Okay, we got everything we need. We're gonna start coding this. So first I'm gonna grab all of this big blob of nonsense, copy, and then I'm gonna paste in my Sublime text, which is already open here. Oh, and now I remember that I have to do this actually. Now you probably can see this better now. Well, sorry about that in the beginning. So I got this. Let's just call this cipher 1. And actually, I I can make this bigger still, can I? Ah, there you go. That's a lot easier to read. Let's also maximize this. Great. And I don't want any spaces because these spaces are not like the real text space. They're just there to make things in blocks, and they're not even blocks of 6. They're blocks of 5, so they don't help us at all. I'm gonna take any space and replace it. There you go. This is a string, and the syntax is Python because that's what we're building it with. What did it do? Oh, set syntax. Okay. Good. So that's the cipher 1. Then we've got this, which is the cipher 2 from here. So cipher 2. I know I put a space there on number 2, but that's okay because I'll delete all spaces anyways. And there you go. So cipher 1, cipher 2, and then we got our cipher 3, which is actually the password, which is where did I cat Krypton 5? Let's do this again. Cat Krypton 5. There you go. Right here. So we got 3 ciphertexts to start our code. Now, to do this, I'm gonna need important things like string, and I'm gonna need pretty print so we can see this better. And then from, what's it called now? I have a cheat sheet here, collections. So from collections, import counter. It's gonna help us a lot as well. Then a few constants like the key length, we know it's 6, and the alphabet length, that we know it's 26. Great. These things will help us. Now, first thing I need to do is just check what are the numbers that represent each letter of the alphabet. I'm gonna make a quick function for that called getAlphabet. Okay, I don't need to declare anything, don't need any parameters for that function. So all I need to do is make a list. Let's call this list alphabet. Not a list, sorry, a dictionary. And then I'm gonna run through all uppercase characters in the ASCII dictionary because I only have uppercase characters. So for, let's say, C in string.ASCII uppercase, I want to make the alphabet on the key C is equals to the character that I have in decimal representation less 64, because the capital letter A is 65. And let me show you here. So I don't need this anymore for now. I'll open Python 3 here, and if I go ord A, that's 65. So letter A is the first letter of the alphabet, 65 less 64. Okay, so there's that, and then I'm gonna return the alphabet. That's what I want, and I'm just gonna declare here my main function. So if, oh, did it happen? Oh, that's pretty cool. I didn't know about it. If name equals main, right. So I want to pretty print the alphabet. Get alphabet. Does this work? I have to save it somewhere now. So let's save this in document, not here actually. I have one project already, Overthewire. And let's make a new one called Krypton, and let's just save it here. I want to save this as, sorry, decrypt.py. Okay, let's navigate there. I want to escape Python, and I want to change this to Overthewire Krypton. Okay, decrypt.py. I want to make this executable, so user bin Python 3. Let's save this. Let's mark this as executable. So crypt. Now we can just call it. And function get alphabet. What? Did I use the wrong folder or something? Reprint. Alphabet is list. It's a dictionary. There's the list C. It's taking that. Yeah. No, that's all correct. Print test. Test. Ah. Oh, okay. Of course, I didn't call the function really. My mistake. Sorry about that, guys. There we go. So here we have the alphabet. So you see A is 1, B is 2, C is 3. Anyways, we can use this for reference. Now that we got the alphabet, we're going to try to work with these strings. To do that, this gets very complicated. Because how are we going to solve this? What is the key to solve this? We know the key length is 6. So what we know is that the first character and the 7th character and the 13th character, they are all being encrypted with the same letter of the first key, right? So for example, if my cipher, if my cipher is like A, B, C, D, E, F, right? I'm not gonna print this, I'm just gonna call this test, just so I can show you. And then I have a key, which is the letter C, A, B, D, P, Y, whatever. So every 6 characters, I'm gonna have the letter C as the key. You see what I mean? So that means the 6th character of my ciphertext is always going to be combined with the key C. Therefore, we can treat this as a monoalphabetic cipher. It makes it a lot easier for us. So that's what I'm going to do. I'm going to grab the first character every 6 characters. Let's try to do this. So let's try to get first letter, and I need to pass the text that I want to work with and the position, because sometimes I want to get the first character, sometimes I want to get only the 2nd character, only the 3rd character, and so on, so I can build the full text. So on get first character, what I need to do now, I need to make a list for the first letter, because I want to combine them, and I want to return them joined. So I'm going to do this already. Return join first letter. Good. So to do that, I'm going to do it for I in range length text that I call. And then I want to return, so this is gonna go through everything there, and I want to return first letter dot append text in the position I times key length, so yeah, every time it's 6, plus the position that I'm offering. So if it's the first character, position is going to be 0. Okay, first letter appends text in the position I times the key length. So every 6 characters is going to iterate. And then I want to divide this by the key length. And because this is going to be a float, I want to force this to be a integer. So int. Does this work now? What if I try to print get first letter of cipher 1 in position 0? Does it work? Okay, looks like it works. So here I have Y, I, Y, W. We can do a quick check here. So I got Y, that's 1, 2, 3, 4, 5, 6. Then I have I, okay. 1, 2, 3, 4, 5, 6. Y, okay. 1, 2, 3, 4, 5, 6. W. Okay, this function works. So we're getting the first letter every 6 characters. Good. Now that we get that, we need to see in this list of characters what is the most frequent character. Because the most frequent character in the English language, that's why I said English was important, knowing that information, is because that character is letter E. Letter E is the most frequent character in the English letter. If I get the most frequent character on this one, very likely it is a letter E. So all we need to do is to shift down to find what was the key being used. So let's see if I can do that. Now, to get the letter, the most frequent letter, I need to print again the counter function on the get alphabet, right? Cipher 1 on position 0. So this will give me that, will it? Get alphabet takes 0 position of what? Oh no, not get alphabet. Get first letter. Sorry. There we go. So letter J is the most frequent one. That probably means whenever there's a J here, it's letter E. Okay. Let's make this a bit more efficient now, and then we're gonna start working with that. So here's what I want to do. First of all, I want more data, so I want to compile all my ciphers into something called ciphertext. So ciphertext is cipher 1 plus cipher 2 plus cipher 3. Then I have more data. Good. Then what we can do is we want to get the ciphertext. We want a position variable to 0. And then I want a cipher. Well, the ciphertext, no, that's what we want, sorry. So then we want to get first letter. Right, first letter is get first letter of ciphertext. What am I doing here? Get first letter of ciphertext at the position that I'm given. So then I can just pretty print the counter of the first letter. Ciphertext position. Okay, this looks alright. Let's try this again. Good. So first letters get first letter of ciphertext, which is everything here at that position. And now I want to call my pretty print alphabet function so I can compare. Good. So here's my alphabet, and here are my common letters. So why do I got letter S now? What? It changed. It was letter J. Now it's letter S. This is confusing. Right. Did I remove position? No. First letter is here. And I'm getting the alphabet. For some reason it changed my values. What? Yes, it completely changed now. What's going on here? What? Okay. What did I do wrong? So ciphertext is everything there. The position is 0. This is returning the alphabet, but it's not even using this right now. Pretty printing the counter of the first letter. So first letter, obviously I'm passing everything here to the get first letter function, and the position is the position 0. So I am joining everything there. Is this changing because, okay, what if I only use cipher 1? It will probably change. Right. What if I use ciphertext, which is everything? Oh, then it changes. Right. Okay, I cannot do this because if I do this, this first letter right here is just going to be appended to the end, and then it's just no longer going to be the first letter. It's going to be whatever letter was there. So we need to get around this. What I'm going to do is I'm going to use this ciphertext 1. Then what about this first letter? Or yeah, first letter is going to be a list. This is useless. Then cipher 1. Then I'm going to add cipher 1 to it. Right. Okay. This is working. Add cipher 2 and then add cipher 3. This way, I know they're going to be the first letters always. Okay. And then I'm going to simply join everything. Equals to Jesus, and so okay. Join first letter. Then first letter equals join first letter. Oof. Okay, now. There you go. So letter J is still the most common letter among all ciphertexts. So that's helpful. Good. Now we can get our alphabet, and then we see here, I want the alphabet goes first. So we see here that letter J is the most common one, and letter J is at position 10. So letter E, being the most common letter in the English language, that's in position 5. Our solution to this is, and I'm gonna write here a comment. So solution, or our formula, is the plain text is equal to the cipher text, let's call it character. So the plain character is the cipher character less, or the most common cipher character less 5, which is the position of letter E. Good. So that means our key, the first letter of the key is 5, because 10 minus 5 equals 5. So it's kind of a coincidence. Now, if I change my position to position 1, which is actually the second letter, right? What we get here now is letter V is the most common letter. So letter V is at position 22. 22 minus 5, that's 17. So the second position on our key is position 17. We can do the same here for position 2. We're gonna do this up to position 5. Letter I. I is in position 9. 9 minus 5, 4. So here is 4. Now in position 3, what we get is letter O. Letter O is position 15, less 5, it's 10. So we could probably automate this, but now we're almost finished. So let's bear with me here. So here letter I again, so that will be 4. And then the last position, C. So that's interesting. So C is 3. If I go less 5, it's going to go minus 2. So what I do is just I go to the top of the alphabet, and that brings us to X, so 24. So 24. Good. That is the key. Now all I need to do is build a function that's going to shift all these letters according to this key. So I like to do this using two functions actually. So one is gonna be the shifter. Then I need the text, and I need a key for that. So all I have to do is make plain text list, and then for I in range of the length of my text, I'm gonna loop through each character of my text, and my text is a combination of all texts right here, or it depends on the parameter that I pass actually. Anyways, I'm gonna loop there, and then I'm gonna call this function shift, and I'm gonna shift the text in the position I, with the key in the position I mod key length, and then I will append this to plain text. So plain text dot append, and then I'm gonna return that plain text. Okay, what I want to do here is that in this shift function, I'm taking each character of the text that I'm passing, and then I will throw in the key at the same character position. However, every time we hit the 6th character of our string, I want my key to be reset at 0, but my text characters keep counting. And that's why this mod function is here. Because once the I goes to 6, it's going to go 6 mod 6, which is 0. So it's going to restart the key. This should work for us. Now I just need to build my shift function, and I also need a text and a key. So the text that I'll be receiving here is actually a character. So maybe let's just change this to character. Okay, so I want, oh Jesus Christ, shift. I'm sorry. Okay. So what I'll try to do here is I'll make a C variable to this character to get the order of this, or the number value of this character, last 64, for the same reason that we did with the alphabet, right? We want this to become like alphabet list, not ASCII list, right? So then I'm gonna subtract the key that I'm receiving. So in this case here, I'll be subtracting 5, which is the first one. Once I subtract that, I want to make sure that this is modded with the alphabet length, because this cannot be more than 26 and it cannot be less than 0. This will catch it, and it's going to kind of rotate it, let's say. Then once this is done, I want to give it back, so plus, to its ASCII position, and then I want to return the ASCII character representing C. Okay, and yeah, that's pretty much all I have to do. So it's going to be passing that text, then it's going to be converting to like an alphabet number. It's going to be subtracting the key, and it's less equal, not less plus. Then it's going to be modding with the alphabet length. It's going to be adding 64 again so it can be ASCII. It's going to return the character, and it's going to append this to the plain text, and it's going to return the plain text, and I want the plain text to be joined. And then hopefully, really hopefully, I don't want this now, I'll have my shifter function working. Let's just try the ciphertext 1 passing the key list. Does it work? No. File on line 29 and shifter, next append shift xi. Name plain text is not defined. Okay. Right, it's not plain text, it's just plain text. Good. So So this string, crazy string here, we found the key and it becomes a readable text. The soldier with the green whiskers led them through the streets of the Emerald City, and so on. So we can just play around here. We could just pass on the cipher 3 here and get the key already. But let's just make this a little bit beautiful and say cipher 1 equals. Then cipher 2 equals, or this is not a cipher anymore, so let's just say text 1 and then text 2, and then we could actually make this a bit more readable like this. So, and finally our password. There you go, and a plus sign here. This is just looking ugly. I don't like it. Let's just do this. There you go. I need to actually pass the ciphertext correctly. Good. Password is clear text. So the text 1 is a story about the soldier. The text 2 is a story about they were obliged to camp. Or probably it's just continuing that story. And text 3 is clear text. Now we could just try it and do an SSH, what is it, Krypton 5 now, at krypton.labs.overthewire.org at port 2231, clear text. Ta-da! So that's it. Very, very exciting challenge. Thank you so much for joining me this time. If you liked it, please like this video, subscribe to the channel for more, and I'm still learning. I'm sorry if I'm making mistakes, if I'm not acting the way you expected, but hopefully we're learning this together. If you have suggestions, feel free to comment. I'll see you next time. And let's close this. Where do I close this? I don't know anymore. That's right here. Bye.